D.C. and the Bethesda area, WTNT. TNT. All right. I want to get open lines fairly soon this hour, but a few things to get in here. President Bush, as you know, said Thursday night he is in fact going to support federal funding for limited medical research on embryonic stem cells. Ending months of anguish on the diverse issue, Bush said his decision balanced concerns about protecting life and improving life. I've made this decision with great care and pray it's the right one, Bush said in a primetime speech from his Texas ranch. I think he made, all in all, probably a good decision. I have a feeling that the pro-life forces on the right are not going to feel that way at all. We'll see. A Palestinian suicide bomber detonated a nail-studded explosive inside a crowded Jerusalem pizzeria at lunchtime on Thursday. It killed 15 people, wounded 90 more. There will be retribution, and I fear soon a Mideast war. NASA has delayed the shuttle launch. Guess why? Thunderstorms. But we'll see. And indeed, the weather is a story. The heat wave that has baked much of the country for days set more records Thursday. The mercury reaching 102 in New York, 103 in Newark, breaking the record for the date of 100 set in both cities in 1949. Up where my network is in Oregon, 108 degrees, hotter than it was here near Death Valley. Here's a couple of emails I thought you might like to hear. Art, here in Ontario, we've had 15 heat records broken this week, coupled, not too ironically, with record severe smog alert days. Temperature has been about 36 to 7 Celsius, or something like 97 or 98 degrees Fahrenheit, with humidity, they say, we're well into the 105s. And to top it all off, at the beginning of the week appeared thousands all over the outside of my clothes. At first I thought it must be normal somehow, and it was just one of those strange bug days that I'd never really noticed before, and these bugs had all hatched at the same time or something. But the paper says they're aphids, and this had never happened in the city before. It said had something to do with them migrating because of the heat wave or something like that. Guess what? They were back again today, and then I got this. Hey, Art. Hello from northern Italy. That's where I am, and these hailstorms are incredible. It damages cars and homes all the time now. 3 weeks ago, there was a tornado by my home near Milan. A tornado that's really unheard of here. I've lived in Seattle for many years, never seen weather like this. Locals say it's the weirdest they've ever seen. And so it goes on and on and on. I get all kinds of email, faxes, and stories about the bizarre weather. Wake up, everybody. The change is underway. Investigators in north-central Montana are baffled by a string of cattle mutilations since mid-June, prompting one agency to seek help from a group that studies unconventional theories, including UFOs. Ranchers in Dubai and Fort Shaw have reported...
Because it's Earth, but it's...
You know, I have a real problem with over-unity because I don't think it's possible, or at least I've not yet seen it demonstrated, even at the toy level.
Right.
I don't want to hear talk about it. I don't want to see drawings. I want to see something that actually demonstrates over-unity. And
well, these people have on the website that I sent you, along with the email,
right?
They show you demonstrating these two machines that they have. That one is a generator and one is a motor, and it's really interesting. I mean, if you just look at the website, you can find that email.
Well, okay, I appreciate your call, sir. Bring me a working model. I mean, let me just lay it out. device to me, and it really is over Unity, I would be glad to give you 5 hours, 4 if it's real soon, 5 hours, though, beginning next week, of a national forum to blast your news to the entire country, in fact, to the world, and to all of the oil companies and all of the big concerns that would go berserk. I really could care less. If you've got it, and if you've really got the goods, then either ship it to me or bring it to me under armed guard. I would be glad to check into it, and then I will give you the biggest national forum you ever saw, and you can tell everybody about it. That's my offer. It's a simple one. There's no money involved. All you've got to do is get your magical over Unity device to me, and I will put you here on the radio, and that will lead to other large media appearances, and you will get your device in front of the world. That's the standing offer. But don't send me talk, don't send me schematics, don't send me pictures. To do it, I will have others step in who are, and I will give you the national forum that'll let you just tell the whole world about it. Now, that's the best offer I can think of. It really is the best offer I can think of. So there it is, out on the table, and we need not have any more talk about all of this. If you've got the goods, you get them here, I'll get it on the air, you'll be a billionaire. Might be just a few months, but you'll be a billionaire. So that should either, let's stop the talk and do the weird in the halls with, you can't turn a corner in a hall at NASA without seeing a bust of Richard C. Hoagland. A science advisor wants to Walter C. Cronkite, an Angstrom Science Award winner, and for years, a very important science adjunct to this program, here tonight saying, well, he said to me on the phone, he solved the mystery of Mars. That's quite a claim. Richard, welcome.
Good evening, Art.
Good evening.
How are you feeling?
Just spiffy, Richard.
Okay. We actually probably have solved a lot of things, and what I want to do tonight is to set up a mystery, and as we go from half hour to half hour, unfold segments of it, and then maybe halfway through, because I know we're going to do an abbreviated show tonight, we'll give everybody the bottom line, but it's really pretty cool.
Can you review the recent news headlines with respect to Mars, the gas and the life in the gas, maybe in the controversy?
These feed directly into the mystery, and for a lot of people, Art, they may not know why Mars is a mystery, so maybe we should start there. Maybe we should kind of quickly give people a thumbnail sketch.
Why is Mars a mystery?
Because it's Earth, but it's not. I mean, for literally centuries, we have looked at it, with the eye, in this night sky is this reddish thing. By the way, I want to talk about your telescope in a little while.
Okay.
Because obviously you have now joined the pleasured ranks of those of us that actually look through real glass and at real mirrors, not at images and, JPEGs and all that stuff.
Yeah,
but,
this thing is
the old-fashioned way.
It really is something else.
And it is, isn't it just totally another world?
Yeah, it's a blowaway.
It is. I'm sitting here looking out the bridge windows of Enterprise at this gorgeous, almost last quarter moon rising over my desert, and it's just breathtaking. And for people who live in cities, the only way you're going to get to see this sky. And this one sounds like it's a pretty cool deal.
Yeah, it is.
And I am not being paid to say this, okay?
Right.
But I'm just so thrilled that you have joined the ranks of those of us for years who have frozen our buns off in the middle of the winter to go out and look at Orion
yes.
and other things. And there are all kinds of neat mysteries. And we will probably not have time tonight, but at some point I need to introduce you to how to marry some of your gadgets to your telescope.
Yeah, I really want to do that.
There is a whole body of knowledge and even websites of people who have taken camcorders and webcams.
Well, yeah, I've got all that stuff. I've even got night vision. I mean, I've got more stuff that I could marry if I could marry it, and I know there is a way. So
it is so simple. There are people, for instance, there was a guy in Boston who works at the planetarium, which was the kind of competitor to the planetarium I worked at when I was in New England in Springfield. And he has published in Sky and Telescope several articles. I guess he's got a book now and he's got a website for how to shoot with a really relatively small telescope amazing views, not just of, the big celestial objects, moon, planets, stuff like that, but he captures things like the space station and the shuttle and produces recognizable images through this shimmering sea of air we call the atmosphere.
Well, it's following the space station, for example, which is very bright and very easy to see. It comes roaring over us here, and it's bright. It's as bright almost as Venus. And if you take a very strong pair of binoculars, you can even see the solar panels on it. You can see the shape, and so it's very exciting. My only problem, Richard, my advantage is I've got this webcam, so if I can get something married, I can put the shots up on the web and just let it continue to scroll. So I'm all for that. Listen, back to Mars. Why is Mars a mystery?
Well, because when you start out looking at it with the eye and then with a telescope, like, for instance, Percival Lowell did at the turn of the century, he thought he saw this faint webbing of artificial lines that indicated there was somebody home, somebody building something, somebody digging something. The famous canals.
Canals, yeah.
Yeah, which were actually discovered in 1877 by an Italian astronomer named Schiaparelli. Well, for 30, 40 years, up until the first couple of decades of this century, a little longer, everybody was intensely debating the canals on Mars like they have debated now Cydonia and the face and all that, because it looked as if, with the technology we had, pretty good telescopes, that somebody might be doing massive global engineering.
Well, that was the debate when I was a child, Richard. They were talking about the canals, and about half the scientists were saying, these are engineered canals for the moving of water on Mars. That's what everybody thought when I was a child.
From the polar caps, yes.
Right.
And the other half thought those first half were crazy.
Right.
Which is kind of the way the whole face on Mars thing is now divided. Half the folks think they're there and, somebody built them or built it and there's an ancient civilization in ruins, and the other half thinks that us half, because I obviously am in that camp, are totally out to lunch. Well, as this debate has evolved, we suddenly entered the space age. This was now in 1957. And in the early mid-60s, in 65, we, the United States, the world, because we represented the world at that time because the Russians had not been able to achieve this, we sent our first unmanned spacecraft to Mars called Mariner 4.
Right.
And in July of 1965, on July 14th, Bastille night, I created to celebrate and to inquire over the flyby of Mars by this first little unmanned spacecraft, Mariner 4.
Mm-hmm.
And it was that spacecraft which basically killed the Martian legend. It basically drove the spike into the whole Lowell idea of, valiant Martians digging canals, preserving their dying civilization, etc., because it gave us the cratered Mars. It gave us the Mars, which has basically no atmosphere. There's no air there. It's 1/100th of the air we're breathing. And it's the wrong kind of air. It's CO2 as opposed to oxygen. And it gave us this battered, ancient, cratered, lunar-type landscape that basically, in one fell swoop, killed all of the romance and the visions and the fantasies and the projections of literally dozens of generations of people who had come before, because it showed us that Mars, if it ever had been alive, it was now dead. It's dead, Jim, and it really seemed dead.
Right.
And then in 71, when we sent our first spacecraft to orbit, called Mariner 9, the Martian legend kind of did a revival. It did a renaissance. Because that spacecraft, which went into orbit as opposed to just flying by, in a few hours,
right,
it photographed over the next couple, 3 years, the whole planet at pretty good resolution. And it showed us that Mars was this amazing place that had incredible towering mountains, vast waters that looked like they had carved, riverbeds and canyons, and, it had polar caps, it had water, it had definite water ice, all right? It had all the essences of potential life that had long gone. That maybe once it had been alive, it had been like the Earth, but in the ensuing billions of years of solar system history, it had taken a divergent path, and it had died, and we had not. And then everyone said, well, now we can do comparative planetology. We can take a look at Mars and see, how planets die. And that was the condition that existed, that kind of, well, there was something there a long time ago, but nothing now, until Viking. Viking was 76, and I, of course, was one of the privileged few to actually be at JPL the night we landed the first Viking spacecraft, and I was sitting there, literally dawn. It was 5 o'clock in the morning Pacific time, as we're landing on another planet for the first time, and those first pictures come in, and on my right is Gene Roddenberry, my dear friend who created Star Trek, and on my left is Eric Burgess, who along with Arthur Clarke and others formed the British Interplanetary Society, and Eric actually wrote the first paper on unmanned probes to Mars, way back in the 1930s. And there were like 1,000 plus other people, newsmen and space groupies and scientists, and I mean, it was just one of those incredible moments when everybody was looking at the dream
At that
fulfilled.
incredible moment, what were the expectations?
We didn't know. I mean, we really didn't know what we would see when those first pictures came in. We knew we had a cold and kind of desolate place, but there was hope. I mean, Sagan, for instance, who was there, had insisted that the cameras have a function that allowed them to record movement, because his greatest fear was that we would land during the day, we'd look out at, let's say, a desolate Arizona, New Mexico kind of landscape, and at night, there'd be rumblings and shufflings, and the IMUs, the little gyroscopes and accelerometers in the spacecraft would kind of detect footsteps.
Right.
But there'd be no lights, and there'd be no way to catch whoever was coming up and sniffing around the lander to see if anybody was home. So there was a feature built into the camera where you could basically take a series of still images and then play them back to detect motion.
Sure.
Like a motion detector.
Sure.
My first picture came in, it was of the footpads, which, I mean, I had argued myself with the engineers, why the hell do you go all the way to Mars, step down, and take your first picture looking down at the ground?
Well, I think I understand that one, so that you can calibrate and understand the resolution your camera has arrived with.
That, plus they wanted to see that there was some possibility that the spacecraft could sink into deep sand dunes. And, we got this vision that they had this picture of the last few instants of picture showing the footpads and the spacecraft being swallowed by dust and sand.
So in other words, they see where the foot is, they get to look at the foot, and they test the resolution, they look at something recognizable,
exactly.
And then look elsewhere. Sure, makes sense, yeah.
The second panorama, a few minutes later, because this thing did not take pictures like, digital pictures now, full frame.
Right.
It wiped them on vertically, line by line.
Right, it's called slow scan.
Slow scan. And it went from left to right, and we literally sat there, 1,500 of us, holding our breath, watching this picture of Mars come in line by line by line.
Mm-hmm.
And it was, well, the really neat thing was when the whole thing had finished, Roddenberry, who's sitting to my right, leaps up and yells, "Cut, print." And I said, "I don't know that man. He's not my friend. I don't know." No, it was just an incredible, joyous moment because we finally were seeing the real Mars, and the real Mars looked like New Mexico.
Uh-huh.
And a few hours later, they got it calibrated so they got.
Actually, that's very good, Richard. It does look like New Mexico.
It does.
Yeah.
Particularly, well, in places like Sedona, which is northern Arizona, which has red rocks. I mean, I've always had this quiet suspicion, as our work has progressed and we've figured out that maybe we're from Mars, that the reason a lot of people like to hang out in northern Arizona is because they're really secret Martians and they like the landscape.
Well, maybe we're from Mars. Did you happen to hear my program last night?
Yes.
It was represented to me that there are ice. There are clumps of ice, clumps of essentially water by the time it gets to the atmosphere, that just bombards every planet, literally everything.
This is Louis Frank's idea.
Yeah, with the seeds of life or potential life, with the ingredients for life.
There are two things going on here. One is Louis Frank's idea. He's at the University of Iowa, by the way. He's not in California, as Stephen said.
Yes.
I've known Stephen Schwartz for a very long time, and he's very good at some things, but his memory for details sometimes. So Louis Frank is at the University of Iowa, and he propounded this very controversial model that the solar system is filled with mini comets.
Yes.
And they are bombarding not only the Earth but other planets.
Sure.
There are huge problems with that model, and we don't have time to get into them tonight, but there's a possible way to salvage the model if they're not solid chunks, but dust clouds of ice crystals, so they have no mass, but they have enough water to feed the second theory, which is a report from a British astrophysicist, actually he's Indian, named Wickrama Singh. I just love saying his name. He's a friend of Fred Hoyle's, who was a very brilliant British astrophysicist who, propounded the steady-state model of the universe back in the 50s and 60s. And Wickrama Singh and Hoyle together have worked for years on the idea of panspermia, that life exists in interplanetary space between the planets, even interstellar space, and that from time to time we are bombarded by comets or cometary stuff that seeds the Earth with viruses and other, small life forms.
Sure.
That in fact life on Earth began because it was seeded from outer space. And he, at a conference in England recently in the last 3 days, stood up and pointed to an experiment that I guess he was involved in, involving a stratospheric balloon that was lofted up to like 40, 45 miles, something like that, and sampled
up to such an altitude where there should not be any living
anything
organisms
from the ground.
From the ground.
Did not get up above the...
Is that a reasonable tenet?
It is a very reasonable tenet.
All right, so he got up there above the life zone, we'll call it.
Yep, because the air currents simply don't propel anything up that high.
And he found
little microbes.
Son of a gun.
And they look weird, and they look alien, and they look definitely non-terrestrial. And if this is confirmed, it would be the first detection of living, breathing little guys.
Would it confirm the theory?
It would confirm the theory that there's something floating around the solar system that we have not been aware of.
That potentially could seed life. Now, obviously, if the planet in question would not harbor life or be conducive to life, then they could crash in all they wanted. There wouldn't be any life.
Exactly. You have to have a fertile petri dish.
Right.
So this is pretty interesting news, and we'll have to see, we'll have to stay tuned and see whether it's corroborated. He's had a lot of flack from some folks, but some support from other folks, and we'll just watch this play out.
What is the argument, Richard? Do some argue yes, somehow something could make it up there?
Yeah, that's the idea, that he's just not recognizing that there are unusual events. For instance, when volcanoes, big ones.
But, Richard, if that were so, they would be recognizable bacterium, wouldn't they?
Well, it depends on how long they've been up there. For instance, we know now that microbes can live in all kinds of exotic environments. In fact, there's a whole term coined for little guys that can live in extreme places.
And in fact, the radiation levels at that altitude would perhaps reshape them a bit, eh?
That's right. These are called extremophiles, and we find them, 20,000 feet down in the bottom of the ocean, and these so-called black smokers. We find them in the hot springs like Yellowstone.
Black smokers are volcanic vents
on the bottom of the ocean, erupting iron sulfide.
And this life gathers all around them. It's absolutely amazing at a depth where there ought to be nothing.
And there's life because there's no light down there, so you'd think there'd be no life, but it turns out that they have a life chain, a metabolic chain based on metabolizing things like hydrogen sulfide bacteria. So you have even complicated guys like clams and tube worms and relatively sophisticated life forms living off this interior energy of the Earth. It's basically geothermal energy.
So if it could happen here, it could happen on another planet with similar volcanic matter.
That's right, like the oceans of Europa, which is one of our ideas.
All right. Richard, we're at the half-hour mark. Gather yourself, take a good deep breath, and we'll be right back. All right. We're talking about Mars. Actually, solving the mystery of Mars to some degree tonight. Richard C. Hoagland is my guest. Don't touch that dial. That is so cool. Not one thunderclap, but two. I just realized I could do that. I did it actually by mistake. That's the way most of these things get started, right? I realized I could do it by mistake, and now I realize I can do it on purpose. Check this out. One more time. A big dual thunderclap. Watch this. Oh, that's really cool. All right. Back now to Richard C. Hoagland. Richard, you're back on the air again.
Sounds like New Mexico.
Yeah, I know. You've been getting a lot of that lately, haven't you?
Yes, it's gorgeous. It really is. One of the things I missed when I lived in San Francisco was that we never got thunderstorms. And one night, very late, many, many years ago, a front rolled through across the Pacific, and we had thunderstorms, and everybody got up. The whole city, Berkeley, Oakland, everybody waked everybody. They called everybody, and there was a huge all-night block party as people watched lightning and rain and heard thunder.
Well, I don't have block parties here, Richard. We have it occasionally. This is the month when we get it. When you have a 100-foot tower in your backyard during a big thunderstorm, you don't go observe the beauty. Well, you do, but you sit out there and mostly pray. Please don't hit my tower, please.
I know the feeling.
Yeah.
Remember, I'm 8,000 feet,
right.
And I have electronic gadgets like you do.
Yes.
And you don't want something to hit. Actually, when it strikes close, the amp is very impressive.
I know.
It's very impressive. So we were talking about life and possible life on Mars, and this Wickrama Singh thing, life, the little bacteria in the stratosphere.
Yes.
And the Louis Frank thing, the possible little mini comets, in fact, is tied in to the potential solution to the mystery of Mars. So we're going to come back to this, folks. You've got to stay tuned.
All right.
Because later in the evening, we're going to tie these two things, which I did not know were connected, back to what we think we have now discovered.
All right. We're also going to have some very interesting photographs for you, probably just after the top of the hour on my website. So stay tuned for that. Stay by your computer. We'll tell you when we're ready. Not yet.
I remember when we could do radio and not have to worry about the pictures.
Well, look, there's nothing like pictures to punctuate whatever you're saying, Richard.
No. I mean, I'm obviously, tongue in cheek here, because we have developed through, your show, this incredible combined medium.
Yeah.
Remember we did the first internet radio simulcast?
I remember. They absolutely should be combined, and I will continue to combine them as long as I'm here, increasing that every time I get an opportunity. Anyway, then there's this gas thing on Mars. I want to understand that controversy, Richard.
Well, this segues nicely because, as I said, in '76, there I was at the JPL with Gene on my right, Eric on my left, and 1,500 friends watching Viking land. Now, Viking was built by NASA as the search for life on Mars, for a good reason.
Right.
The idea was you'd land this VW-sized spacecraft by remote control, because it's 8 minutes away by the speed of light, so there was no hands-on law. We literally were getting our data 8 minutes after everything had happened. So it either happened or it didn't. There was not a damn thing anybody could do about it. Mm-hmm. So we get the pictures, and then a couple days after, the little hoppers in the top of the spacecraft opened up, and an arm reached out, a kind of a remote robotic arm, and the computer, under pre-stored ground commands from JPL, picked up the soil sample, brought it back, and then dumped the soil in the containers on the top of the spacecraft, kind of equilibrating, between the first and the second and third experiment. So everybody got their samples, and then the instruments went to work. Now, what NASA had done is to go to TRW, which is a major aerospace company in Southern California, and they had built into about a cubic foot of space. Cubic foot is about what, the size of your monitor, maybe?
Right.
They had built an incredible, complex, remote-controlled biochemistry laboratory, 1 cubic foot, and sent it 40, 50 million miles away to Mars and set it down on the surface. And the idea was that this laboratory would sniff and sample and, examine the stuff going on in the 3 chambers and report from 3 different experiments whether there were any microbes in the soil.
Let me represent the average person now. That was a long time ago, Richard, and as far as I knew from then, there wasn't much to be announced. And now, all of a sudden, now in 2001, we're getting some sort of announcement about something they found then. I just don't get it.
I love the way you mentioned the number 2001. Because there's a lot of things happening this year that I think it's kind of time that they happen.
Well, okay, but they answer my question. I mean, why are we hearing about this just now? Is it some...
Well, according to the story, when I was there, so I can tell you what happened at the other end of this pipeline 25 years ago. The 3 experiments did their thing. And all of them reported positive results, Art. Every experiment that NASA did in this gadget said there's life on Mars. And those of us who were watching were absolutely dumbfounded because the experiments had been designed to look for opposite kinds of chemistry, and you couldn't have a positive registering life if there was opposite stuff going on the soil. In other words, it was like having a yes and a no answer simultaneously. And then there was a fourth experiment called a GCMS, which was basically designed to measure organics, to measure the dead bodies. On Earth, when we have life going on, we have hydrocarbons involved. We have hydrogen, carbon, nitrogen, things like that. And there's organic residues left over, dead bodies. This gadget was designed to sniff the soil down to the parts per billion level, that's with a B, and detect the residue of life, the dead bodies. Well, it didn't detect any dead bodies. It didn't detect any organic chemistry at all. And so NASA officially said that the three experiments which had, quote, positively detected life, couldn't. That, in fact, it was what they called funny chemistry, having to do with a very weird surface, a highly oxidized, a super oxidized surface of Mars, given its peculiar history and environment. And, in fact, it was only chemistry, it wasn't life, and everybody go home and nobody get excited. Well, one guy wouldn't go home. His name is Gil Levin, Dr. Gilbert Levin. I think I've discussed him a couple times on your show briefly.
You have, yes.
And he ran a company called Biospherics, Inc., and he and his co-investigator have insisted for 25 years that their experiment, in fact, did detect microbial life in the soils of Mars, and NASA simply changed the rules in mid-game.
Why?
Well, that's a huge political discussion, and I don't want to kind of get off into politics tonight.
All right, okay.
But what he has been doing is he has been pursuing every possible loophole to try to counter the official NASA position that we didn't discover life, or his experiment didn't discover life. Now, his experiment was called the labeled release experiment, and the theory was as follows. You basically put the soil in the chamber, and in his gadget, his little vial, you then dropped in a little nutrient, which was called affectionately chicken soup.
Okay.
It was actually a complex organic compound. And the idea was that the little beasties, the little microbes in the soil, if they were there, if they were alive, they would glom onto the chicken soup, they would eat it, and they would then respire, I mean they would outgas, exhale carbon dioxide like microbes do here on Earth.
Right.
The difference was this chicken soup was laced with radioactive carbon-14. So as they exhaled their carbon dioxide, the gas would float up to the top of the chamber, and there was a little radiation detector up there that was supposed to measure the amount of radioactive carbon locked up as CO2.
Okay.
And when everything worked as advertised, I mean, instrumentally, engineeringly, this was an incredible tour de force. I mean, we did an incredible job in 1976 because everything worked. The only thing that didn't work was the interpretation, the scientific reception of what these gadgets were trying to tell us. Because what happened in all these experiments, but particularly in Levin's experiment, is that the labeled release thing worked. The gas came off, CO2. The radiation detector measured the carbon-14, which is how it knew how much gas was coming off. And over the next 9 weeks, Art, 9 weeks, that's 2 months plus 1 week, right? This thing continued to evolve. Now, they did controls. They then dumped it out, flushed it out, put new soil in, started it up again. They got the same reaction, and then they raised the temperature to about 160 degrees centigrade, like an oven. And that was supposed to kill the microbes, to sterilize them, and you would then see if you had any reactions after that,
right.
And the reactions went away. Poof, gone, bang, flat, dead line.
So
right?
then why didn't they announce, oh, my God, life on Mars?
Because they couldn't detect in that fourth instrument any organics. And they claimed that that was their control, and that if they couldn't detect the organic residues of little microbes, then there couldn't be microbes, and therefore there couldn't be life, and there had to be some kind of weird oxidizing chemistry. Well, Levin spent 25 years, a quarter of a century, almost as long as I've been pursuing the Cydonia thing. He and his team had been pursuing the idea that they did detect life, that NASA politically didn't want to admit it for whatever reasons, and he's been up against a very stiff uphill climb. In 1999, a guy named Joseph Miller, who's a neurobiologist and a circadian rhythm expert.
Mm-hmm.
You know what circadian rhythms are, right?
Yes, I do.
Yeah, well, for folks who don't, every biological organism appears to have an internal clock. And even when you isolate organisms ranging from microbes to bacteria to mussels to frogs to us, in the dark, away from light and dark, there is this internal clock,
right,
which tick, 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 and seems to somehow know the planet's rotation, the day of the planet you're on.
Sure.
So this guy, Miller, somehow had a chance to look at Levin's data 25 years later, back in 99.
Mm-hmm.
And he was struck by the fact that as the gas came out and was measured by the radioactive detector, it showed little peaks and valleys. Ping, ping, ping.
Right.
And they looked like they corresponded to the Martian day. So he said, oh, my God, maybe. So he went to NASA and he said, get me all this Viking data. And they said, Dr. Miller, we kind of have a problem there because we lost it.
We lost it?
They lost it. And so they scurried around and they finally found, he thought it was on one of the NASA websites, like everything is supposed to be out there somewhere.
Yeah.
It wasn't. It wasn't anywhere to be found. Now, he's assuming a benign interpretation. You know me. I think there may be a less benign, but let's not get sidetracked. He finally got some people to get him the original magnetic tapes. And lo and behold, they had been programmed in an arcane machine code that was so primitive compared to what we're using now that the programmers had died. There was no way to get the data off the tapes. So then he gets hold of Levin.
All right.
Fortunately, Levin had made paper copies of everything and was able to supply him with this. And together, over the last year or so, it's 2 years, since 99, 2.5 years, they have been working to restore this data, and Miller has been subjecting it to the kind of controls and statistical analyses that his profession brings to it, neurobiology and circadian rhythm studies.
Right.
And last week in San Diego at a major conference, he published a result which is pretty astounding because he claims that what Levin has found is evidence, unequivocal evidence, of biological activity in the soil which exhibits the circadian rhythm of the 24.66-hour Martian day. And
all right, Richard, again, on behalf of the normal person, why should we care whether there is microbial life on Mars right now or not? I mean, basically, it's a wasteland. If Mars once was alive, as we understand major life, it is not now. And if there is microbial life there, what difference is that going to make to us?
Well, in the context of your discussion with Stephen last night, and in some of the things you were doing in the first hour, we should care because planets are not immortal. Planets can die. And it is this incredible, vibrant, living world right next door, and something terrible happened, or a series of something terribles, and we could be inadvertently doing stuff to our world that would bring on the same catastrophe.
Yes.
We got to know that because we got to be able to take another road. We got to be able to take the left fork and not the right fork.
I see that clearly.
The other thing is that if there is life on Mars, then it presumably had a history. It had an origin, it had an evolution, and if it's there now, it exists in its current condition because of all the things that have happened to it.
Yeah, I think certainly it's fair to say if it once had the water on it that we think that it had, or even that we know that it had, then there could have been big life there. There could have been complex life there, and if there was, I mean, you're absolutely right. We need to know for that reason. In addition, there are a lot of people talking about the possibility of terraforming Mars in case we might need it. So I can see all that.
And, of course, is there a heart that is so dead that it doesn't want to know if it's alone? Because as Carl was so fond of saying, if we find so much as a microbe next door on Mars,
sure,
it means the galaxy, the universe, is
life,
teeming with life.
True.
And, of course, it would back up with the science the claims of all the UFO people that there are folks visiting, and claims like us that there might have been an ancient civilization there, and it would be an extraordinary, even to find a microbe, but what you're going to hear tonight as we get through the rest of our mystery is that we're thinking now there's a lot bigger stuff than microbes. And what's amazing is that what we think may have happened to Mars may have left only the microbes alive. Everything else that we think could have been there may now have been deceased.
In other words, everything larger than a microbe
is gone.
Deader than a doornail.
Because of what happened to Mars and what could happen to this planet. It comes back to what do you do about your home? How do you protect life and limb and home? And so looking at Mars is not an academic exercise. It's a cautionary tale in if you don't do this and this and this, maybe for the grace of God you'll go that way too.
Well, Richard, we do know there's a long history of probe failures to Mars.
Incredible, statistically weird failures, yes.
Is it so weird that there is some external force at work, whether it be earthly or otherwise, in your opinion?
Well, as I said on the PAC show, my bet is that if there's any weird forces, it's political. Its missions don't die, they're just kept from us who are paying for them, because they find things that those guys don't want us to know until the right time. Well,
going to Mars or any other planet is a chancy thing to do, and there are going to be failures, but there does seem to be a very disproportionately large number with regard to Mars.
Compared to other places we have gone, which are a lot more hostile, like when you go toward Venus,
yes.
toward the sun, it gets hot.
Yes, oh yes.
Electronics don't like hot, okay?
Right.
They like cold better. When you go to the big planets like Jupiter, Saturn, they have huge radiation fields, and we got a Galileo, which we're going to have to go out there and beat to death with a stick, because it's just going and going and going. In fact, they're going to dive it into the atmosphere in a couple of years to permanently get rid of it so it won't, clutter up the radio channels and possibly collide with Europa.
Actually, it's diving in with a bunch of plutonium, isn't it?
Yes, just a little bit. Not a lot. It won't do anything. That's not going to don't even go there, all right?
Okay.
That's not a real problem. The point is that technology in space works extraordinarily well. We've had Pioneer spacecraft that were sent to Venus back in the 60s that are still alive 20, 30 years after they were launched.
That's true.
The fact is that going to Mars, which is a relatively benign place, it's right next door, it's just a little further from the sun than we are, the Russians and even us lately have had an extraordinary series of, quote, failures, boys and girls.
It really should be the easiest place to go short of the moon.
That's right.
And it's really the hardest. Richard, hold on. We're at the top of the hour. We will be right back.
I've been drifting on the sea of heartbreak, trying to get myself ashore for so long, for so long. Listen to the strangest stories, wondering where it all went wrong for so long, for so long. But hold on, see what you got.
Richard at 1-775-727-1222. The wildcard line is open at 1-775-727-1295. And to Richard on the toll-free international line, call your AT&T operator and have them dial 800-893-0903. This is Coast to Coast AM with Art Bell on the Premier Radio Network.
It certainly is. Good morning, everybody. We've got the visuals up now to go with the discussion we're about to have. Let me tell you how to get to them, all right? You go to artbell.com, and when you get there, you go to Program over on the left-hand side. Simply go to tonight's guest info. Repeating, tonight's guest info. There you will see the name Richard C. Hoagland. The first thing you'll see is images, Mars illustrations for tonight. Click on that. There are going to be 9 illustrations there that we're going to be talking about. So if you start up to the web right now, you'll be able to follow along with us. Again, artbell.com. Go to Program, tonight's guest info, and right under the name Richard C. Hoagland, you'll see the images for tonight. Click on those and follow along with us. Richard C. will be right back. Stay right where you are. All right, back now to Richard C. Hoagland. Figure number one, the first figure is sort of an introductory photograph. I suppose it's a photograph of Mars. And boy, is it a good photograph of Mars. Richard, that's really a pretty picture of Mars.
Isn't that gorgeous?
Yeah, it's gorgeous.
Well, it's not a photo. It's a piece of art.
Oh, well, that's why.
And it's a piece of art as Mars may have looked many, many, many hundreds of millions or even billions of years ago.
Yeah, I thought it looked a little blue.
It's very blue. And there's water running down Valles Marineris.
Yes.
There's an ocean on the left.
Yes.
Toward Olympus Mons. There's blue sky. There's Rayleigh scattering. There are clouds. It's warm. It's wet. And this is part of the mystery. What we're going to talk about for the next couple hours is the work that I and Mike Barra have been doing for about a year, quietly with a number of other colleagues, to try to put together all the pieces of the puzzle ever since 71, since the first Mariner 9 images that told us we had a place that was maybe like the Earth once and was nowhere like the Earth now.
Mm-hmm.
I mean, the temperatures on Mars are extraordinarily cold now.
Oh, can I ask about one more thing?
Sure.
The recent storms on Mars.
The dust storm.
Yeah, the dust storms. You know, I've heard from varying sources that dust storms of the magnitude they're having actually shouldn't be possible.
That's one theory. It's an interesting theory. I mean, we know they occur roughly every couple of years when Mars comes around closest to the Sun, and we only really get to see them when we're closest to Mars, when it's closest to the Sun, which happens roughly every 17 or 15 years.
But, I mean, these are monstrous storms.
Well, you got several things working for you. You have a very thin air, thin atmosphere.
Right.
You have an extremely dry surface. I mean, it is bone dry.
Right.
So when you stir up dust, even in a thin atmosphere, there's no water to wet it. There's no wetting agent. It doesn't stick together. Mm-hmm. It's been dry for many, many millions of years and getting drier.
So it's kind of like out here where I live, so dry that when the wind blows, it picks up
everything.
Yeah, that's right.
Now, except on Mars, it picks it up, and there's no precipitation falling to bring it back down. There's no nucleation, or very little, which would make it bigger and clump together and make it fall.
Yeah.
So that's why when Viking landed, we were astonished to see that the skies looked pink.
So then it's it's how close it gets. In other words, when it warms up, when it's closer to the sun.
Mars' orbit is not circular like the Earth's.
The energy is sufficient to get it going?
Is sufficient, and plus you're tilted, that hemisphere, the southern hemisphere, is tilted toward the sun, so you get an enhanced effect.
Okay.
On Earth, we have a tilt, 23.5 degrees. Mm-hmm. Mars is tilted 25 degrees. Mm-hmm. The tilt creates seasons, right? Mm-hmm. On Earth, we're closer and tilted toward the sun in the winter in the northern hemisphere, so the two things kind of moderate. Even though our orbit is pretty circular, it's not exactly a circle. Mars is very elliptical. It's quite elliptical, egg-shaped. And so you can get millions of miles closer to the sun on Mars and in the southern hemisphere summer than you can the northern hemisphere winter. So the summers on Mars are warmer, and the winters are colder by a lot than they would be if the Mars orbit was circular.
Okay.
So the dust storm that we're seeing erupted from a place called Hellas, and like the one back when Mariner 9 went into orbit in 71, it quickly spread around the entire planet, so for weeks you couldn't see anything but dust.
That's right.
You got your telescope just at the wrong time, Art.
I know. Although it was really, I could clearly see the storms. It was incredible.
Well, I was watching before the storms. Ha-ha. And it was, in fact, that was the night we were going to do the show, the night it was closest.
Yes.
And then you had to leave a little early.
Yes.
We had an incredible view, and all kinds of neat, mysterious things have happened. But the view you see on the screen now, for everybody watching, on web TV or on their computer, that is the view of what we now think Mars may have looked like hundreds of millions of years ago. And what we've been trying to do is to piece together the puzzle that would allow us to say some very certain things that had never been said before about Mars, and by the end of the evening, we hope to be able to tell you how we got there.
Okay.
This all comes down to water. It all comes down to where did the water go. That's why Mars Observer and Mars Surveyor were sent.
Right. Because
NASA, since 71, has seen these incredible evidences of ancient water, vast canyons carved by rushing floods and streams and tributaries and ancient rivers, all bone dry now, all sitting there under their, 100th atmosphere of Earth.
Yeah, water is life. Water is life.
And water is definitely connected to life. If you don't got water, you don't got anything.
Right.
So where did the water go? Well, about a year ago, when we finally got our first sets of pictures. This is now the second picture down, Art. All right?
All right. Let me go.
In July, a little over a year ago, we published on Enterprise a photograph right after the NASA press conference on water. Remember where they announced they'd found evidence of arroyos?
I do indeed.
Of erosion that looked like it could have been maybe 1 million years ago.
Sure.
Could have been yesterday, but there was no liquid water. Well, we found some images, and this is one of them, which show things, dark, streaky stains.
Yes, indeed, dark. Indeed, dark.
That appear to, look, for all the world, they go from high-level stuff down to lower-level stuff, downhill.
I see that, yes.
And you can see here several different versions. There's real dark ones, then there's lighter ones, then there's real light ones.
If this is moisture being represented,
that's what we
and
saw.
It does look like it's going downhill, folks. Take a look for yourself.
All right.
Inevitably, the darker, the further down you go, the darker it gets, indicating the water's pooling down below.
So this has been a mystery now for about a year, and we were the first to publish and claim it was liquid water. And here's the model we actually presented on Enterprise of June.
Coming from where?
Coming from underground. Coming from water that is being melted underground. Because remember, the temperatures refer to the surface, air temperature. But you know, living in the desert, that it can be relatively comfortable standing up, but if you put an egg on your sidewalk out in front of the house, it can actually fry.
Yeah, that's right.
So the ground can be warmer and can trap energy more than the air. The air is very thin on Mars, so the air temperature is very, very cool all the time. But the ground temperature can get up to 50, 60, 70, 80 degrees.
Mm-hmm.
Did you know that?
I had heard that, yes.
And this was measured by Lowell and guys with telescopes and now been reconfirmed. So the ground near the equator can actually rise well above the boiling point of water. I'm sorry, the liquid point, not boiling point.
You mean the melting point of ice?
Exactly.
Yeah.
In other words, above 32 degrees Fahrenheit.
Sure.
Now, the theory says, well, wait a minute. Even if you had water, as soon as it hits the air, it's going to evaporate. So if you have a liquid pool, it'll go poof. It'll disappear within minutes. But if you wet the ground from underneath, and the ground has certain properties, and we'll get into that in a minute, you might be able to have liquid water that would stay liquid, wetting the ground like a sponge. You know how you can wet a sponge from underneath and it seeps up through?
Sure.
It would stay liquid for hours or maybe even half a day before it evaporated, depending upon the kind of soil and where the water was coming from, how deep.
Okay.
So we looked at these last year and we said, holy, whatever,
Folks.
It's liquid water.
Mm-hmm.
And as soon as we said that, NASA said, you guys are crazy. It's dust. These are dust avalanches flowing down hills, etc., end of discussion. Mm. And a whole bunch of people in the so-called anomalous community.
Well, how do they know?
Well, they don't.
They're looking at the same photographs we are, right?
That's right. And we've had now geologists, we've had Ron Nix look at this, we've had a lot of other people look at it. There have been a lot of independent investigators, people like Efren Palermo and Jill England, who are two people I really want to cite tonight because they did some amazingly good scientific research which allowed us to create the paper that we have published on Enterprise.
Richard, you can even see in this photograph some of these downhill shadings which are almost dried up if you imagine it's water, and at the very bottom it's darker, as it certainly would be if it was liquid.
If it's cooled under gravity and the bottom has more than the top.
No question about it.
Drying slower.
Yeah.
Now notice that there are light ones in between.
I do, yes.
Okay. Everybody who's ever lived in the Midwest or in the mountains knows that you have a terrible problem, the so-called bathtub or bathroom sink stain problem, which is caused by calcium carbonate.
That's right.
Or any one of a number of other minerals.
Right.
If you were to have mineral-laden springs underground, soaking up through the sand and the dust, and wetting it and looking darker because it's wet, and then drying, what you would get as a residue after that process had gone would be the minerals that are left.
Right.
You get the white stuff, and you can see some of these streaks now, instead of being dark, they're light.
Yes.
Well, we were pretty convinced that we were looking at liquid water. And then other people picked up the cudgels. As I said, Efren Palermo put up a website, and he started culling through thousands of Mars images for the stains, as we've called them, of
Yes.
stains, because
Yes.
they're dark stains, right?
Yes.
And he's got an incredible website, which is linked to Enterprise, if you go down a little bit, where he mapped, he basically looked all over and he put up images and images and images. And finally, I got together with him this past spring, and I said, Efren, have you made a map, a global distribution of these images?
Right.
Because if we're looking at water art, our idea was it should be around the equator, because that's where it's warmer.
Sure.
It might even be seasonal. And if you looked over enough of Malin's pictures covering a couple of Martian years, you may be able to decode all that. Well, he set up a global Mercator projection, and he involved a very bright young gal named Jill England, who is a statistician. She is a whiz at mathematics. And what she has done is gone through, get this, all of the 70-plus thousand images from Mars that Malin has given us.
Right.
And done a statistical analysis, a first-rate statistical analysis, which they, by the way, have put into a paper that they're publishing at the Mars Society conference in, I believe it's, in a few days in Denver, the annual conference of people who basically want to send manned missions back to Mars.
Yes.
Their paper was accepted, and what it shows is that the distributions of these stains is very, very weird.
It is. I'm looking at figure 3 jumping up.
That's it. Jump down now to figure number 3.
Yeah, okay. And
because
we're looking
this is
at
Efren's map.
We're looking at a 180-degree difference from a planetary point of view, correct?
That's right. You've got a big cluster of stains in one place on Mars, and then if you looked at Mars as a globe, and we'll get to that in a moment, 180 degrees away on the other side of the planet
I'll be damned.
are where the rest of the stains are.
Yep, there they are.
And there's nothing in between.
And you've got them coded. The red dots indicating stain images.
That's right.
The yellow dots indicating light stain images. And
Now,
the green dots indicating
this is
non-stain.
Efren and Jill's coding, but as I said, we suggested that he do the map, and this became the central mystery all spring into the summer. We've had all kinds of, discussions among ourselves.
Yes.
What in the world could be causing this distribution? Now, this distribution has a name. It's called bimodal distribution.
What does that mean?
Bimodal means it's got two poles.
Oh.
It comes up in two places.
Right,
meaning
okay,
two,
right, gotcha.
like bipolar disorder.
Sure.
There is no way that these can be dust. Because dust, the airs of Mars flow all around the planet. You have global dust storms, boys and girls. That's what we just stopped discussing, right? So how can you falling down, steep cliffs and other places on Mars only in two areas that are 180 degrees apart? So I looked at this, I looked at this, I looked at this.
You can't. It's water.
No, it's got to be water. Well, let's put it this way. It has to be a fluid.
A fluid of some sort.
It might not be. If you want to be very scientific.
Water's a good guess.
Water's a very good guess.
If we think there was a lot of water on Mars, then it follows there could be obviously be water below the surface
but
on Mars.
As we said in our original note last year, those dark things could be oil.
Well, it could be.
They're so damn dark.
It could be.
Tommy Gold, you know Tommy Gold?
And the way it's going, in about 35 years, it'll be financially worth bringing oil back from Mars.
George, you hear that? You want to drill in Anwar? I got a place for you.
Yes, indeed.
Long pipeline. Very long pipeline. Anyway, Tommy Gold, who was a brilliant astrophysicist, he actually was the one who coined the term pulsar and neutron star.
Yes.
He has proposed that the oil on Earth is not due to organisms, little biogenic things, ancient guys buried by sediment.
I thought it was dinosaurs, yeah.
Or dinosaurs, we're digging up T-Rexes and putting them in our gas tanks.
Right.
He is claiming, with some reasonable evidence, that the production of oil is not biological, but is chemical. And, it involves hydrocarbons, but those are made, naturally as opposed to with life, and that any planet with enough chemistry should have deep layers of oil under its surface, even if it never had life.
Well, then shouldn't there be here on Earth more oil forming underground?
But it takes a long time to form.
Oh, well, I understand. But shouldn't they be able to see, even at the macro level, some development of new oil?
It would depend on where you're drilling. And in other words, how would you know if you're drilling into a pool in sediments that it isn't a biogenically formed?
Well, shouldn't they see something in process, Well,
Gold's theory is so controversial, and it has not been really tested yet. I think they tried to test it in the Baltic Sea.
I'd be more comfortable with the fluid idea, the water idea, even than oil.
Well, but you have to be kind of objective here and say it could be another fluid. Back down to the map, all right?
All right.
Because the map is gold. I mean, this is where Efren is hopefully listening tonight, because we've not told him what we figured out from his map.
All right, everybody. For those of you that don't have computers, the two areas 180 degrees apart at both poles of Mars are just filled with these red dots that would indicate some sort of stain images, serious stain images. Elsewhere on the planet, you've got mostly green, which means non-stain images. It's just impossible. It's absolutely impossible. It probably is water. Okay, I'll give you that, Richard.
Well, the thing that is conclusive that it's got to be a fluid and most likely water is the next graphic down. Because I'm looking at this, and I'm looking at this, and I'm suddenly thinking, oh my God, what would give you an unmistakable bimodal double pole 180-degree signature? Tides.
Tides, indeed, yes.
If you look at that diagram, this is listed from a guy named Michael Payne.
Yes.
And what people don't realize, even though we live on Earth, even if you live near the seashore, most people don't realize that we, for a very good reason, have 2 high tides a day. I mean, you living in a desert, you wouldn't know anything about this, but presumably when you were out in Okinawa or places like that, you watch the ocean?
Yes, Richard, I've watched the ocean from time to time.
Tongue in cheek. The reason we have 2 tides is because the moon is the culprit here. The moon raises gravitationally a lump of water on the one side of the Earth. That's where you have 1 high tide. But what most people don't know is that on the other side of the Earth, exactly the same moment, you have another high tide,
right,
180 degrees opposite. And there's some funny little physics, and that diagram explains it if people want to go and kind of study it. But, we don't have to get into the details, but on every body where you would have tides...
Yeah, actually, I would like to understand that. Hold on, Richard. He's right. We have a high tide on this side, which is facing the moon. I understand, I think, the physics behind that, but I don't understand the physics that would create a high tide on the other side of the Earth, which is not seeing the moon, or the influence from the moon. We'll ask about that. I am kind of curious. I can understand the physics, I think, of why we have a high tide when the moon's looking at us. But why would we have one on the other side of the Earth? Richard?
Okay, let me try to do this simply. And for folks who don't have computers, you're going to really have to think about this mental picture.
All right.
When the moon is over any part of the Earth that has an ocean, there's a bulge of water pulled up toward the moon by the moon's gravity.
Right.
All right. The Earth is also rotating at 1,000 miles an hour.
Right.
So even if we didn't have a moon art, there would be a kind of an inner tube of water around the equator because of the centrifugal force effect of the rotation.
Okay.
Like slinging a bucket of water around your head.
Sure.
On a old piece of rope.
Right.
Which, in fact, I actually did one day and had very interesting results. This was a long time ago. Science is experimental, and sometimes you got to experiment, even if it means blowing up your mother's kitchen. Well, that's another story, so we won't go there either tonight. Anyway, so we're on a rotating planet, and you got gravity plus centrifugal force.
Okay.
So the bulge toward the moon is even a little bigger. But why do we have a bulge away from the moon?
On the other side, yeah.
That's a really interesting puzzle, and a lot of people don't understand it. So let me try here.
Try me.
Okay. It's because the force of gravity from the moon is not linear. In other words, it isn't constant.
Okay.
It decreases with distance.
Okay.
And it decreases rapidly with distance. That's
right.
why they call it the inverse square law.
Right.
So by the time you get to the other side of the world, which is 8,000 miles farther from the moon
yes,
than the side facing the moon, the force of the moon's gravity is significantly smaller.
Right.
So the centrifugal force that's spinning up the inner tube of water
yes,
can spin it up high on that side because the Earth is being pulled out from under it differentially. It's that differential force. It's the difference between the moon pull and the centrifugal force of the rotating water on the rotating Earth.
Yeah,
you wind up with 2 bulges. Opposite.
Yeah, but It seems to me it ought to be the opposite of that. In other words, it ought to be a low tide there because the moon continues, albeit a lesser pull, and as you're looking at the side of the Earth, it seems to me that would pull it toward the bulge, which would make it a lesser tide on the opposite.
It would be if we were just sitting in space and suddenly moving toward the moon.
Right.
But because we're in orbit,
okay,
you have that bucket effect.
Okay.
And it's all in the rotation. Remember, rotation?
Yes, okay.
Now, tides like this, because planets are going to orbit other bodies anywhere in the galaxy, anywhere in the universe, you will have two lobe tides, bimodal tidal distribution on any planet with tides anywhere in the universe.
So then your theory is, with regard to Mars, that that tidal effect is what produces the water bulging from the ground on opposite sides.
That's right.
Okay, I got it.
But here's a big problem. What is causing the tides?
On Mars.
On Mars. It has no moons. I mean, it has two little tiny potatoes.
Not enough.
No way. And the sun, tidal force, by the way, goes as the inverse cube. The height of tides is as the third power divided of the distance.
Okay.
So by the time, we have small solar tides on Earth. They're about half the height of the lunar tides.
Mm-hmm.
But by the time you get out to Mars, any solar tide is insignificant. Plus, Mars is rotating. 24 hours, 37 minutes. Half an hour longer than it takes for the Earth to spin.
Okay.
Why would you have two tidal signatures permanently now on the surface, fixed in time?
I don't know.
That's where the break... I got to tell you that the emotional high, pun intended, of coming up with the answer to this and finding it was the answer to a whole series of mysteries going back to Lowell's time. It answers so many questions. That's why we've written this 32-page paper that we have published on Enterprise. You just go to enterprisemission.com or go through your website to us, and right at the very top there's a big banner that says attention. You're going to be swept away by the tides of Mars. And we explain in much more detail than we can tonight how this now answers so many extraordinary mysteries of Mars, including what happened to Mars life.
Okay, well, answer it. Why do they have tides?
Why do they have tides? Because it has to be an echo. It has to be telling us about an ancient Mars, a condition, a situation where Mars was close to a big object with good gravity, which maintained those tides.
Yeah, but that accounts for it then, not now.
Because, well, here's where things get more interesting. Okay, go to the next graphic down. All right.
Okay, here we have a picture of, I guess, Mars.
Here we have Palermo's map. Computers can now take Mercator and wrap them around spheres.
Right.
So what we did is we had Efren wrap his map around a globe of Mars, and you wind up now. Look at the various captions. You wind up with most of the stains are on what's called the Tharsis bulge.
Right.
Fewer stains are on the opposite side and what are called the Arabia bulge.
Right.
And I've got here a graphic showing a tidally distorted ocean. If Mars had an ocean, that egg-shaped thing is aligned.
Yes.
So and to the right it says 2 planet 5.
Yes. That would account for it then. But how now, Brown Cow?
We'll get there. All right. Remember Tom Van Flandern? Tom Van Flandern has maintained for many, many years that Mars used to be a satellite of a bigger guy in the outer solar system.
Gotcha.
Near the asteroid belt.
Right.
We think tonight, boys and girls, we have proven Tom is right.
How?
Because of the tides. If Mars existed as a satellite relatively close, within, let's say, 100,000 miles, what would happen is it would become tidally locked. Like the moon goes around the Earth, so you only see one side every month.
Right.
Mars would go around the big guy, so it would always see the same side. If you were standing on the big planet with Mars as a moon, you'd only see one hemisphere.
Okay.
We have a weird situation. We've had it since the 70s when Mariner 9 first went into orbit. They found that there's this huge bulge in Mars. Go down to the next graphic, okay?
Okay.
This is a MOLA graphic. The MOLA is the Mars Orbiter Laser Altimeter.
Yes.
It's bouncing, pinging laser pulses, measuring the altitude of various things under the spacecraft orbiting Mars now.
Right.
So it's developed this incredible, complete Mars map of the altitudes to an error rate of less than a few centimeters.
Okay, I'm on it.
Okay. Notice that the red stuff, if you look at the key at the top.
Yeah, what does that indicate?
Okay.
What that color scale, what does it mean?
The blue stuff is low.
Right.
The red stuff is high.
Okay.
Look at where the red stuff is.
They're opposite. Yes.
Opposite.
Roughly.
Yep. Now, the one on the left is reversed from the previous diagram. The one on the left is what's called the Tharsis Bulge, where all the huge volcanoes are.
Yes.
Olympus Mons and
right.
Arcia Mons and all those others.
Gotcha.
The one on the right, kind of down at the 4 o'clock position,
right.
is Arabia Bulge.
Right.
There are 2 bulges in the crust and mantle of Mars that have never been explained. They are unique in the solar system. The Tharsis Bulge is the biggest bulge on any planet we've ever visited or ever surveyed in the last 40 years of NASA, and is completely mysterious, totally, bafflingly mysterious to every mainstream planetologist within the sound of my voice.
Unless there was another big body there.
Yes, because what would happen over long periods of time, Art, is things get frozen in.
Right.
They get deformed. Planets are plastic.
Okay, I understand that.
You don't think of rock as being plastic, like toothpaste.
Okay, I'm with you all the way.
Okay.
Except, Richard.
Let's go down to the next graphic.
Okay.
And you're accept.
Okay. I'm there.
All right. The next graphic shows a schematic version of what we think happened. Mars got captured sometime between the origin of the solar system 5 billion years ago and X time. Back in time, millions of years.
Right.
Mars got captured.
Okay.
By a planet that used to exist out there where there's now but rubble. And remember Tom's idea?
Sure.
That there were a couple of planets that blew up?
Absolutely.
Well, we may not have to go that far. We may just have to smash them together. And it would have the same effect. If they were big enough and they collided at fast enough speed, you get the equivalent of a huge explosion.
Right.
And what that would do is liberate Mars. So this is the schematic of Mars before it was liberated, before it was released in this event.
Okay.
And what you can see is it would rotate around the big guy, maintaining the same face toward the planet. We think it would have rotated around 24 hours, kind of like its rotational period now. That's the ancient relic rotation revolution period.
Yes.
And it would raise bulges, both in the crust and in the oceans.
Okay.
Now, if this occurred, all right, several important other things would happen. That huge bulge, the Tharsis Bulge, has all those big volcanoes. What do big volcanoes do, Art? They belch stuff out.
Right.
And what kind of stuff is it?
Well, molten stuff, rocks, dust,
and gases.
Ashes, gas, yeah.
Gases.
Yeah,
and
yeah.
that's where we think the Earth's atmosphere came from. In fact, we think the planetary atmospheres of so-called silicate worlds,
yes,
Earth-like worlds, all comes from volcanoes belching out their guts from the inside on the outside.
Okay.
And exhaling gases that then form the atmosphere.
Right.
Then on Earth, life modified the atmosphere because these primitive atmospheres would be CO2.
Right.
And they'd be nitrogen, and they'd be other things, trace elements. But ultimately, for the last 500 plus million years, life on Earth has transformed the CO2 into oxygen, nitrogen, things like that. So our atmosphere is very atypical of the normal planetary process. But in terms of its ancient origins, it would have been the same on Mars. Big volcanoes mean lots of belching, mean lots of atmosphere. Mm-hmm. So as you wind up with Mars in this tidal configuration, you wind up augmenting the internal heating process, particularly if Van Flandern's also right that this big guy had another moon. Now, you remember what's going on in the Jovian system right now, where you have these 4 moons, the so-called Galilean satellites?
Yes. And
they're nudging each other gravitationally.
Right.
And they wind up inputting energy into Io, and it's got all that volcanic activity we found back in 1979 with Voyager.
Yes.
Similar situation could have gone on with one other moon in the Planet 5 system. All it would take is one other moon, and there'd be enough tidal disturbance of the rotation revolution that you'd get, basically it's like bending a wire back and forth where the wire gets hot. The energy gets dumped into the interior. It's belched up as in volcanoes. The volcanoes add to the gaseous atmosphere. So you get a very dense atmosphere, much denser than the one now, 100 times denser.
But, Richard, I'm sorry, I still do not understand. If there is interior water in Mars, what is causing the tidal effect that brings it to the surface at 180 degrees?
You're getting there. You're getting there, okay? But you got to have a little foundation here. So the ultimate upshot of all this is that Mars would have had a dense atmosphere. And the denser the atmosphere, the more it traps heat from the sun.
Right.
It's called the greenhouse effect.
Right.
With enough greenhouse, you get nice balmy temperatures.
Sure.
You get liquid water. You get liquid water for potentially hundreds of millions of years. All right? So what then happened is, according to Tom and according to our separate calculations, either the big guy exploded, or that's our next diagram down, or it got collided by the other planet, so-called planet K in his model.
Right.
Either way, you would have had an incredible detonation right on Mars' doorstep. And on Mars, there's a huge southern hemisphere that's absolutely peppered with craters,
right,
shoulder-to-shoulder craters. This diagram demonstrates how we think the craters formed. It's the debris from the explosion of the planet. What that did, and that's our last diagram, is to release Mars back into a solar orbit all by itself.
I take it this final picture is indeed a photograph of
Mars.
It's
a photograph taken by Hubble a few days ago.
Boy, it's a beaut, too.
Isn't that gorgeous?
Yeah, it is.
Yep. It's, by the way, the Cydonia side of Mars.
What is what's the blue at the top and bottom?
That is water ice crystals and CO2 that are scattering sunlight, like blue sky. That's clouds. It's a vestige of the atmosphere. So let me go to the last steps. In this model, which I'm really thinking is real, not only would you have the planet deformed into those two bulges in the crust.
I understand.
The oceans, the water would have collected, Art, in two oceans clustered over Tharsis and over Arabia.
Okay, I can
buy that. Planet, all right, and it would have sat there for millions, if not hundreds of millions of years.
Sure.
What happens when the planet blows up or it gets collided? You suddenly lose the gravitational tidal lock. Suddenly, this condition, which has existed for, maybe 500 million years, is released. The gravity field suddenly goes away.
Mm-hmm.
The tides of Mars are gone.
Right.
And the water is released to rush at headlong velocity, hundreds of miles an hour, back to the lowest places on Mars, which is in between the two oceans.
Right.
We see these incredible huge channels. That's why when we talked the other day and you said they just found these incredible big channels.
Yes.
Guess where they are? They're right at the edges of this ocean. They're where the waters would have rushed for 1,000 miles, 150 miles wide, and carved incredible channels in the crust because of the vacuum forces of that much water rushing at that speed over the surface under Mars gravity.
Mm-hmm.
And what we're now saying is that the water that we're seeing in these stains opposite on both these poles, these tidal oceans, are the ancient seabed waters coming up from underneath the ground where there used to be the ancient oceans.
But doesn't it take some kind of remaining tidal pressure to force that?
All it takes is temperature, heat. And all it would do is, remember, the only place water can go is up. If you melt it, it will flow upwards.
Right.
It will percolate upwards.
Sure.
So if you had ancient seas sitting over two places, think of two round oceans on both sides of Mars, and then they're suddenly released and the atmosphere goes away, you have massive impacts, most of the water and the atmosphere is literally vaporized and blown into space. We're talking a catastrophe of unimaginable biblical proportions.
How large do you imagine these underground oceans to be?
Well, they're not oceans. They are the remaining rivulets of ancient water. Now, here's something important. Under the current Martian conditions, it would be very hard to maintain liquid water, right? At the recent Lunar and Planetary Science Conference in Houston, two Russian guys from the Russian Academy of Sciences, from the Institute of Geochemistry, proposed a model where if you add salts to water under Mars conditions, it can be liquid even well below 10, 20, 30 degrees below zero.
Sure.
And what would you find on the seabeds of two ancient oceans, Art?
Salts.
So we go down the list, ping, 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 every mystery that they are now propounding. The discovery of huge channels, the bimodal distribution of the stains, the strange atmosphere, the weird presence of sulfur. Do you know that Mars has a lot more sulfur on the surface? 43 times more sulfur than the Earth does?
This should mean that if we were to go to Mars with man, or even with a robot, we could drill into the appropriate areas and find water pretty quickly.
Oh, it's got to be close to the surface.
Yeah, exactly.
In these regions. Now, here, remember, any scientific theory, and again, I want to call people's attention, if you go to the Enterprise website, you follow the links at the top of the main page, you'll go to the paper. We have it in PDF form because, Art, we are so convinced this is real that we're submitting this to scientific peer-reviewed journals to be published under that process. Now, it's going to take a long time because you can't send them simultaneously. You've got to send them one at a time. So you get rejection, rejection, rejection. Somebody is going to publish this in a peer-reviewed journal. It is that good. It answers every single mystery. Now, your question, where do you drill? Obviously, go to the two places where you have stains.
Right.
And that's where you put your manned base. That's where you drill because that's where the water is, and you can easily filter out the salt. That is trivial, all right? But you've got lots of water there if this model is correct.
Well, I asked about that. When you say lots of water, how much water?
Well,
maybe.
Certainly, given the number of stains we're seeing and the fact that we now have a time constant, we know that they appear and darken immediately.
Yeah. All right, once again, Dr. Richard C. Hoagland in New Mexico. And Richard, I think you've made a pretty convincing case that the water is under those two areas. What I guess I want to know is, what does that really mean for us? Does that mean that a manned base on Mars is feasible? Is that
trivial, because if there's that much water, and we're talking a lot of water, residual water, then everything that Robert Zubrin and the others that want to go Mars Direct and the fast and cheap and not the NASA $400 to $500 billion mission, but their $30 billion maybe, is totally doable. That's the first fallout of this model. And let me tell you why the stains are so dark. I mean, the deeper we get into the model, pun intended, deeper title model, the better this gets. And for those people who can't download PDF files, I've been getting a few faxes like, what the hell do you mean putting the PDF up there? We're doing that because that's what we're submitting to the journals.
Right.
Tomorrow, next day sometime, we will have an HTML version on the web-friendly for all the web TV.
So they can just read it directly.
So they can read it direct,
Okay.
The reason this is such a powerful model and so amazing, and I want everybody in the planetary community out there, to the anomalists, all the people following the Sidonia, up and down, back and forth, to basically think about this, because if we are right, this is not only the keys to the kingdom of putting man on and women on Mars now, cheap. George, are you listening? But it's the key to solving what happened to Mars in the past and whether there was anybody home. And that's the thing that I'm so excited about, because this now allows me in Heritage to lay out, to preview tonight, but to lay out in detail the past history of Mars and what happened there that paralleled what happened here.
Why do you think Arthur C. Clarke is suggesting there may be now large life still on Mars?
This falls out of the model. Get this, okay. If Tom is right, and you know how Tom Van Plander created the idea of a possible other set of planets out there and Mars as a satellite?
Yes.
Based on the celestial mechanics of comets and asteroids?
That's right.
You can't really cheat celestial mechanics. It's pretty simple stuff. And he basically sees the signature in his evidence of explosions or collisions, all right? Sequence.
Yes.
We've got a Mars now with all these tidal signatures. That's the part tonight I'm totally firm on. Mars was tidally bound to a big object. It then was released. How it was released, whether it was an explosion or a collision, is almost irrelevant. We know from the data now that Mars had to have been captured into this orbit, 24-hour orbit, and held there for a long time. How long? That's the key $64 million question. How long? Tom says that this all came to an end, a catastrophic end, 65 million years ago, right?
Yes.
That's when the dinosaurs bought it.
That is indeed.
The dinosaurs bought it because a fragment of the colliding or exploding planet hit the Earth and killed them.
Yes.
Okay. So that's our end stop. That's when Mars went to hell. You know, Elton John's Mars ain't the kind of place to raise your kids because it's cold as hell. Well, that's when Mars got cold as hell, because that's when the Garden of Eden period, as I'm calling this, came to an end. But the real question, Art, is how long did it last? Now, I can get into the details if you want, but I'll give you the number. We think that Mars was in this tidal lock condition for about 500 million years.
Wow.
500 million years. Now, why is that number important? Because that's the same number as it took for the Earth to create all the advanced life we enjoy on Earth tonight. We had something called the Cambrian explosion of biological diversity 540 million years ago. Scientists, paleontologists, biologists, evolutionary guys all say that that's when we went from little bacteria that cover the Earth to suddenly a huge explosion of evolution where all the advanced families, all the advanced forms that we find now,
big jump,
so-called body plans of big guys, suddenly appear. And the Swedes think that it may have happened in as little as 5 million years. And it set the blueprint for everything that's happened in the last 540 million years.
It has always been a mystery, yes.
Huge mystery, and I will try to solve that one in Heritage. It's too big to tackle tonight. But the interesting thing is that from our separate work on Mars, it looks like Mars was captured about the same time as advanced life on Earth was basically appearing.
Now, would all of this lead you to believe that there was some sort of advanced civilization on Mars?
Well,
and that during this specific period, the one that you identify there and here, they made their way from there to here, being aware of what was happening?
Kind of. This is what we think happened. You had a primitive Mars with little guys in the soil, little bacteria.
Yeah.
Mars gets captured. The Tharsis bulge in Arabia begin to develop under the tidal forces.
Right.
They belch out gases. They create a greenhouse effect.
Right.
You get warm temperatures. You get rain. You get oceans. You get volcanic activity putting out chemicals. You get lightning. Remember your lightning zapping the little warm pond you talked about with Stephen last night?
Yes.
You get a parallel development with similar temperatures and a similar amount of time, and I'm going to argue that you had similar type evolution.
I think that a reasonable person would conclude that.
Yeah. Now, last year when we found the water stains and published them, we also found some other things that frankly were so unbelievable that I kind of buried them in the middle of one of our reports. We found things, Art, that look for all the world like huge fossilized life forms. I'm talking huge. I'm talking enormous.
Life forms?
Life forms. Ancient skeletons. And we have them on our website. All right? I don't have the link up there right tonight because we published them a year ago. And I can't prove it yet because I haven't talked to him, but I'm beginning to suspect, because Arthur C. has been following what we're doing at Enterprise.
Apparently. I
think that that's where he got the idea that the glass tunnels may be big ancient fossils of worms or living worms. Now, I can grant him that they might be fossils. They might not be, Lincoln tunnels or Holland tunnels like we've been saying. They might be organic forms, but they might be ancient organic forms.
Real Martian worms.
Exactly, like in Dune, all right?
Yeah, like in Dune.
Like in Dune. Now, the reason that biology would have grown so huge on Mars compared to our normal experience, Mars is not the Earth. Mars is smaller. It has a lighter gravity. It was under a very peculiar tidal condition, which does things in my physics model that would precipitate big life. Mm-hmm. But remember, we went through a period on Earth of big life, did we not?
Very big.
Huge things that could not exist on Earth, by the way. Jurassic Park, I think, could not happen now because the gravity, well, let me put it to you this way. If I'm right, when these planets blew themselves to pieces or collided and the fragments were scattered to the wind,
yes,
the physics of the solar system went down a peg. So big stuff can no longer exist. But back in the heyday of the solar system, when everything was hunky-dory, you had huge biological developments on, if we're right, 2 worlds, not just one. And we're seeing in these photographs some of the evidence that Arthur is jumping up and down about. Now, I don't think they're currently alive. I think they are dead. They're fossilized. But if that's true, it means that you could find a tremendous panoply of the whole biological spectrum on Mars waiting for human expeditions like you have here on Earth. And it isn't going to be hard to find the big stuff because they're huge. They are enormous if we're right. And we published them, as I said, last year. You probably may have missed those images, but they're just astonishing.
Oh, you're right. I missed them.
Well, I'll tell you what.
I certainly saw the glass worm.
I will put up tomorrow on the web the reposted link to them so everybody can see what these big possible fossils look like.
Okay.
But they're just so, they just look so organic. Robin, who has a medical background, she looked at them, she says, those are like skeletons. They look like the cross-sections of a bone where you get the honeycombing.
Well, they actually do, yes. Sure they do. I also saw some pictures that you put up of what appeared to be, I could swear, even to my eye, it looks like foliage on Mars.
That's the trees.
They look like trees. Yeah, they look like trees.
Well, they could be from an ancient, remember, they're now frozen and uncovered at the poles, and there's no oxygen, so they'd be covered and uncovered with CO2. Frost, snow,
right.
Like dry ice. How do you preserve
but that's exactly the way they look.
You pack them in dry ice, right?
That's the way they look.
So if these are primitive ancient organisms, they may be preserved, and I think they are going to be huge. I think this is the big untold story of Mars. When we finally get there, we're going to find that life was there, and it was big. The old joke about the 800-pound gorilla.
Right.
Well, think about this, though. If you had big life, and if you had enough time to develop all the incredible intricacies, say that later tonight, intricacies of life on Mars as we did here, what's to stop it, Art, from going to intelligence?
Well, nothing.
What this now gives us, and I'm really believing this, guys, it gives us a basis to say that the ruins we see at Cydonia and all those other places is indigenous Martian intelligence before the catastrophe. And if that was true, and they knew their planet was going to buy the farm,
yes,
where would they go? Where would be the only other place in the whole solar system you could go?
Right here.
Here.
We would be the obvious choice.
Yep. Now, we got to adjust the time scales because there are parts of the time periods that don't fit yet, but that's because we haven't thought long and deep enough. This has all kind of come to a head in the last month. We've been really working on this paper, and I'm so proud of it because Mike and I, have really put our heart into it. It's 32 pages, 74 references of all the current things that have been found and all the little pieces you have to put together in the puzzle to support and document your model. Nothing doesn't fit. That's what's so astonishing. There is not one mystery. I sound like, the great Carsoni, right? Not one mystery is not explained by this model.
But, Richard, if there was large life on Mars and ultimately intelligent life on Mars, particularly life that could have made it to Earth.
Yes.
Shouldn't there be far more remnants available to see, even if they're drastically misshapen and almost gone, just as there would be a New York City to see sort of in a mangled form for millions, if not billions of years?
Just look at the pictures. You have not had time. Arthur, of course, has a lot of time down there in Sri Lanka.
Yes.
And he has looked and looked and looked. Now, he has a mission going back. 2001 Mars Odyssey, the NASA spacecraft, is 80-some days away from planetfall at Mars again. Mm-hmm. It's going to go into orbit in October. By December, it will be in a position to test this model, Arthur's own spacecraft. The day was launched April 7th.
Well, the one named for him.
The one named for him, yeah. Well, they didn't do that because they had nothing better to do.
No, most people get spacecraft named after them after they're gone.
After they're gone. Yeah. Well, Arthur's very much alive, and he's going to have one hell of a good time because he sent an email, which I've got, to the project manager at Lockheed Martin.
Yes.
The day it was launched.
Right.
And he said, I'm not quite willing to believe in artifacts yet, but go find them. Mm-hmm. And I think that's his tongue-in-cheek way of saying that he knows more than he's telling. And he's basically giving everybody a hint that they have to be there. Now, what will his spacecraft do that will test the tidal model? It carries 3 instruments. Are you aware of that?
What are they?
Okay. One is called TESS, which is a thermal imaging system. It's going to give us surface composition data,
right,
with much higher resolution than the Mars Observer in the infrared. So it'll give us materials, what stuff is made of down there.
Right.
Number 2 is a instrument called GRS, for Gamma Ray Spectrometer. It's going to basically look at gamma rays, which are very high energetic electromagnetic radiation, very high energy, that are emitted by nuclear events. And what it's going to look for is the interaction of cosmic rays, because Mars is bathed by cosmic rays like the Earth is. And what that does is generate secondary emission from certain elements. It can look at like about 20 elements, from hydrogen up through silicon and aluminum and things like that. So it's going to map with this gamma ray gadget the distribution of elements on the surface.
Okay.
It's going to look at the hydrogen. Now, what is the most likely form that you will find hydrogen on any planet?
Water.
H2O, right. So it will map the hydrogen. Science is nothing if it's not prediction. A key prediction of this model tonight, Art, on your show and in our paper, is that when Odyssey gets there and begins mapping in December with the gamma ray instrument, it will find two anomalous bimodal pools of hydrogen on both sides of the planet, Tharsis and Arabia, and almost nothing in between.
And that would certainly solidify your model,
Indicate the presence of underground water.
Agreed.
Okay. Number two, it carries a gadget called Maria, which stands for Mars Radiation, et cetera, et cetera. And NASA claims that they're measuring the ambient environment to see if it's safe for astronauts.
Okay.
And I said to, I forget who I told this to, that it didn't make any sense because the Mars radiation environment is the same as here. Mm-hmm. We already have measured it with spacecraft, so who needs to measure it on Mars?
Okay.
But maybe there's a hidden agenda. God, NASA having a hidden agenda? God, I can't believe I said that. Maybe they already know all this. Now remember, we know now tonight that Mars had to be tidally locked around a big planet. And that planet got destroyed somehow.
So if they already know this, what are they measuring for?
Because there are two modes of destruction. One is the collision,
yes,
which is kind of normal, and the other is the explosion. Remember, Tom's biggest problem has been he can't explain to folks how you blow a planet up.
Right.
You can't go out and get the Acme planet blowing up kit in the back of, those, remember the comic books that used to have all these ads?
Oh, sure.
You can't buy one and do it in your garage, thank God. We think the hyperdimensional physics model gives you more than enough energy to blow a planet up. And if that is true, when Odyssey gets there and begins measuring the radioactives on the surface,
yes,
if the planet was destroyed and the material splattered on the southern hemisphere, there should be very weird radioactive signatures still there.
Very true, yes.
From aluminum-26 and magnesium, I forget all the elements, but we have them in the paper, all right? Those should be incredible crystal clear signatures of an anomalous nuclear class event, because blowing up a planet involves nuclear energy level energies, and they should be splattered all over Mars, and that's what the GRS and Maria would find and map if, in fact, that's true. Now, why would that be useful to a manned-Mars mission? Because if this all took place 65 million years ago, which is just yesterday, some of those isotopes could still be hot, Art.
All right.
And they might be too hot to land near, so you don't want to land where there's a big radioactive thing.
Uh-huh.
So that's why Maria, I think, is being carried on Odyssey.
Okay.
Because they're measuring the environment to basically
but since they've done it before, what are they saying about why they're remeasuring?
No. They've only measured here. They've never measured on Mars.
Oh, I see. Okay.
But the only environment that we know is radioactive is cosmic rays. So if you measure cosmic rays at the Earth and you measure them at Mars, it's the same thing. Cosmic rays come from the galaxy. So there's no source of radiation near Mars, or there shouldn't be, unless it's the surface itself, which is still hot from the detonation the blue planet will come.
Okay. And the third device?
Well, there's the thermal camera, there's the GRS, the gamma ray measuring, and Maria, which is the Mars radiation instrument.
Okay.
Maria is the acronym.
All right, so you're hoping this will then verify everything you sort of just said.
Basically, and that's the test. The first test is where is the water, and the water should be in two pools under those ancient oceans of Tharsis and Arabia.
But if it is, this means a manned mission, a Mars base.
Is cheap. Because we know how to do it. The problem is living off the land, as Zubrin says, and this would allow us to live off the land.
Live off the land. Live on Mars. And perhaps even begin slowly converting Mars to make it
to what it was.
All right, hold on, Richard. We're at the bottom of the hour. My guest is Richard C. Hoagland, and he's laid it out for you, what he thinks the mystery of Mars was and is, and what it would mean for us, and might mean for us relatively soon if we get off our butts and get on the way back to Mars. We'll be right back.
Richard Bell in the Kingdom of Nye. From west of the Rockies, dial 1-800-618-8255. East of the Rockies, 1-800-825-5033. First-time callers may Richard at 1-775-727-1222. Or use the wildcard line at 1-775-727-1295. To Richard on the toll-free international line, call your AT&T operator and have them dial 800-893-0903. This is Coast to Coast AM with Art Bell on the Premier Radio Network.
Well, you've got to admit, what Richard has said tonight makes sense. I suppose now the next step is to get all of this peer-reviewed. And should it come true, should all of this begin to bear fruit, then I guess we know where the manned mission to Mars would go. There'd be no choice about it. It would go where the water is. You gotta love the double one. That's really cool. Once again, back to Richard C. Hoagland. Richard, you're back on.
Ancient lightning on Mars.
Oh, man, that sounds so cool.
It is.
Yeah, you listen to that as you watch the last picture, the one really taken by Hubble of Mars. That is really a cool picture.
Yep, and there's water there. That's what the blue is.
Yeah.
Right?
Yeah.
And, there's a loop. Now, we can go further. We can tell now what happened after this incredible catastrophe.
Okay.
And, it's like, what would have happened? The waters would have been released from their tidal lock. I mean, imagine two oceans sitting like two huge circular swimming pools on opposite sides of the planet.
Right.
For hundreds of millions of years. What happens with tides, Art, is that the whole planet gets deformed, like you're like squishing an egg.
Sure.
And the water in between, because of the way the tide, we have a diagram in the paper that shows how the force lines go into the planet at right angles to the tidal line.
Yes, sir.
So basically, there's a band around the middle of Mars that would be really bone dry, and all the water would have been on these two poles. Now, why would it just sit there? Why wouldn't it go like the Earth, the tides go around the Earth? Because the planet was locked with one side facing Planet 5.
Mm-hmm.
It wasn't rotating like we are relative to the moon.
Which, of course, is why you believe they put the artifacts, like the phase on Mars, facing in that direction.
That's right.
Yes.
And the angles and the tilts and the geometry. And by the way, these so-called tunnels that we found, the glass tunnels,
yes, sir,
which are all helter-skelter, they now, if that was a living site, if that was a city, as we say, and there are other places around Mars, but that one is the one we've looked at, obviously the hardest, they would have had to have water, right?
Yes.
Where would the water have to come from? From one of the two oceans.
Right.
Right? Except for a little rain, which would quickly go away, the main water would be on one of those two oceans, so you'd have to construct pipelines to bring water to that desert strip in between.
So we now might imagine that these incredible tubes we see
are the huge conduits for water, and the reason that they're all helter-skelter is because of seismic energy. People have said on the web, I mean, there's a lot of anomalies now. Researchers, commenting and looking and sharing data and all that.
Yes.
There's a huge growth industry, which I'm so glad to see because it takes a huge burden off what a few of us have been trying to do all these years.
Mm-hmm.
It's now unstoppable, and I'm hoping this community looks at this model, says to NASA, you guys have got to fess up and be serious about this and go back. Just like you said, we need the manned mission now. But one of their complaints has been about the big tubes as man-made, as artificial, is that they appear not to have an orderly geometry. Well, this model explains that.
Well, I can imagine that. In other words, the amount of geological action that would have been going on would not give them much geometry, except at the micro level.
At the moment of collision, when half that planet got hit by the explosion,
yes,
I've calculated, based on models which are, again, referenced in the paper, the amount of seismic energy that would have been imparted to Mars. Can you say Richter 15 earthquake?
Yeah.
Do you understand what would happen? I mean, not you, but everybody out there in the country, if the ground were to shake with a Richter 15 earthquake? Every number on the Richter scale is 10 times the previous number.
Right.
So the earthquake that leveled San Francisco was 8.6, I think, back in 1911.
Something like that, yeah.
All right. Imagine an earthquake 1,000, 10,000, 100,000 times greater, all over the planet.
Well, would shake everything to the ground.
That's right. Or if they were made of stern stuff, which we think they are, it would make them go all cockawampus.
Sure.
All right? And so there would be no pattern left. The only pattern would be the integrity of the links themselves, if they are artificially made. If they're organisms, huge organisms, they would have died at the moment of the impact.
Absolutely.
All right? So you're looking at fossils then buried by material falling on top. I was going to get back to why the stains are so dark and how really cool this is, all right? Because when Viking landed in 76, we got our first surface chemistry, okay? And one of the things that popped out of the chemistry, which is the actual analysis of what the elements are,
yes,
was an anomalous amount of sulfur. There's 43 times more sulfur on the surface of Mars than there is on the surface of the Earth. That's a lot.
That is.
Now, where does sulfur come from? Well, it turns out that sulfur is beneath our feet. It's buried in the mantle and the cores of planets. Mm-hmm. If a planet spews its guts all over you, all right, you're going to have a lot of surface sulfur.
And so you do in volcanoes.
And that's what we have. And,
right.
and we have, exactly, volcanoes are belching up sulfur from in the mantle of the Earth. This sulfur on the surface appears now from the Mars Global Surveyor data to be in the form of sulfates, which are oxidized forms of sulfur. But I turned to a chemistry friend of mine. In fact, you know him. Remember the guy that I connected you with for the chemtrail problem, Mike Castle?
Sure.
I called Mike and I said, okay, Mike, I've got this chemistry. What happens if I wet it? What do I get? And he said, oh, you get, and then he gave me the equations of what you would get. The water coming up underneath, even if it had a salt in it, interacting with the sulfur-rich surface stuff,
right,
would produce sulfuric acid, which would then react with the iron. There's a lot of iron, right? That's why it's red.
Sure.
To produce iron sulfide, which is pitch black. So I think the stains are pitch black iron sulfide from the surface sulfur iron materials being wetted by water from underground. Mm-hmm. Then over time, 5 years, 10 years, 20 years, the little bit of oxygen that's released by the ultraviolet working on the CO2
right,
would oxidize the iron sulfide back into iron oxides and sulfates. So they would go back to faded ground. Except if there are also salts in this water, the salts would remain as a whitish stain. And if you look at that picture, number 2,
yes,
you can see this sequence in these images. Old, medium, and young stains.
Yep, you can.
Go through this. So again and again, the specifics of this model answers every. I would love to open lines. We have 15 minutes, so we probably can't do it tonight. But I'll bet there isn't one question that could be posed about Mars now that this model cannot answer. That's how powerful and confident I am that we're really onto it.
Well, do you think you're going to be able to get good peer review?
It's all a matter of the politics. If people out there really demand that there be honesty, and we know there are a lot of young churches in the planetary science community who listen to your show, who look at our websites, all right? That's why we're putting this paper in PDF form so they can download it in the conventional format.
Sure.
It's kind of like when Playboy used to be so avant-garde, people would take it home in a brown paper wrapper. Can you imagine 3 o'clock in the morning, various planetary science guys tiptoeing down to their dens and logging on to Enterprise and downloading the paper?
Sure.
So no one knows? But because it's so powerful and it answers so many things, what I'm really thinking is inside the system, even if we don't get it published in a peer-reviewed journal, with the net now, it's almost irrelevant.
It almost is.
Because the net is democratic. The net is everywhere, and everybody talks to everybody, particularly with email. So it's going to get read, and we're going to make sure we're going to send copies to all the key people in electronic form so they can't avoid having it come in their mailbox. It's going to have to take root somewhere because it answers too many questions. And if you're serious about finding out, if you're really a scientist at heart and you want to know what makes things tick, it's got to percolate down to where even if they never acknowledge that we came up with it, which I doubt they would do, like Europa, it will get used and moved, and it will move the process, and we'll have missions based on this model, and that is another political prediction tonight. I think this is so powerful. You know, an idea, whose time has come, that it will get used even if it's abused, and we, again, kind of get ignored. But in the short term, I don't care about that because, as you said very rightly, or opening the show, if this is true, if the water is there in the amounts we now believe, it makes a manned mission mandated for a whole bunch of reasons and economically trivial to do.
How hard would it be, assuming that you are correct and the water is there, for a manned mission to derive everything they would need to virtually sustain life? I don't see that part yet.
Well, here's what happens. You land on Mars where these stains are, and there are areas, by the way,
Fine. Let's say you find water.
All right. How close to the surface is the water?
Let's say it's close. Let's say
close.
It's easy. Fine. You find water.
Okay. What does water give you? Water gives you oxygen.
Yes.
Right? So you don't have to take a lot of oxygen.
Right.
Water gives you water.
Right.
One human being takes how many kilograms per day to live?
Yeah, but where do your hamburgers come from?
Well, you take it as freeze-dried food. But you can also, if you want to live as a colony,
yes,
you build greenhouses. If you've got water, you've got hydrogen and oxygen. We know from the Viking, element list, you got all the other stuff. To assemble a biosphere again, the key missing element was the water. If there's enough water there, particularly if it's mixed with other things, you filter out the other things, like they're having to do in the space station. They take up water and then they don't even recycle it. They kind of dump it into space because they don't need to recycle it in the space station, but you need to recycle on a long mission to Mars, or else you'd have to take a huge amount of weight.
Sure.
If there's water there, it's again the Lewis and Clark model. Lewis and Clark did not take everything with them. They ate along the way. Mm-hmm. They hunted along the way. Mm-hmm. Well, you can't hunt on Mars, but you can grow things. You can grow chickens. You can grow, the soy burgers. You can grow all kinds of plants, corn and soybeans and other things, provided you got water.
They would be able to extract enough oxygen from the water for their needs and for greenhouses and or whatever else.
Absolutely. But what else does water give you? It gives you rocket fuel.
Hydrogen
and oxygen.
Yes.
You split it with solar energy or nuclear energy or hyperdimensional energy, one of these gadgets you don't think exists, which do, and you have all the rocket fuel you'd ever want.
All I ask is you deliver me one.
All right. You're on. Okay.
I'm awaiting.
Okay. The point is that with water, known supply, able to be seen on the images, where you can land there on the map and know you can drill down 3 feet and get to it,
mm-hmm.
you have licked the problem of the manned Mars problem. And you have made it incredibly cheap. Zubrin has got a neat idea. By the way, you ever talked to him? Ever had him on the show?
No.
You should have Robert Zubrin. And we should, in fact, you should have both of us, and we should go over this model and have him look at it with you kind of like the arbiter as to how it helps him politically accomplish his dream, which is to get men and women to Mars quick.
Richard, what would a manned presence on Mars do for us?
Well, in the long term, if we're really going to louse up planet Earth, if we're going to do dumb, stupid things, if the climate's going to hell in a handbasket and chemtrails are a desperate effort to paper it over and keep it, us all fat and happy until it's too hot,
mm-hmm.
It's our lifeboat. And I frankly think that NASA has been working on this for a long time, quietly and gently, and we've published many.
That would imply they know, in all likelihood, or perhaps positively or absolutely, we're going to need a lifeboat.
That's right. Now, if you go to Enterprise, if you go to the top of our page, you will see this logo. In fact, can you do that, Art, while we're talking about this? Because I want to comment on something, all right? Go to Enterprise main page.
Okay, I'm working on it.
At the very top, under the Now Hear This, we have a rectangle. And we say in the rectangle, attention, in this year of discovery, 2001, the Enterprise mission announces the launching of a major new research initiative
that will forever change the way you and the world looks at the origins of Mars. Prepare to be swept away
by the tides of Mars. Now look at the thing on the left, the logo.
Yes.
That's the official NASA JPL logo for the Mars Surveyor program. And look at Mars.
Yes, I'm looking.
Okay.
It's half modern Mars and half...
And where is the ocean?
Yes, indeed.
It's clustered in one little area.
Right.
Like a tidal Mars.
It absolutely is. Yes, take a look at it, folks. It's true.
Now, one of the cool things in our paper is that we have a painting by Arthur Clarke, my dear friend Arthur.
Mm-hmm.
About 10 years ago, he published a book called The Snows of Olympus. That's back when computers were kind of newer, and he was all jazzed by something called Vista Pro, which allowed him to mock up synthetic worlds in the computer.
Right.
And he chose Mars, and he did scene after scene after scene, and he was entranced by Olympus Mons. Olympus Mons is this huge volcano the size of Arizona or Kansas, Dorothy, sitting on the top of the Tharsis Bulge at 19.5 degrees, by the way.
Mm-hmm.
That's also in this model.
Right.
And around this huge volcano, the biggest in the solar system, I mean, you know, one volcano the size of Arizona, I mean, give me a break. That's enormous. Now we understand because it was extruded in the regime of the tidal influence of Planet 5. But around this huge volcano, there is an enormous cliff, Art, 22,000 feet high. 22,000 feet.
Big cliff.
That's one hell of a hang gliding cliff, right?
Oh, it sure is.
Nobody's been able to explain this cliff. It is our proposal that this cliff was because Olympus stuck up above the ocean. And that cliff is where the water, for hundreds of millions of years, beat against the shore, like the White Cliffs of Dover, and eroded those basalt lava flows into vertical or semi-vertical cliffs. They're actually 20, 30-degree angles over hundreds of millions of years. When Arthur did The Snows of Olympus 10 years ago,
yes,
he painted a scene, which we have in the paper, of Tharsis surrounded by an ocean beating at those cliffs.
Hmm.
Now, he claims that that's what will happen if we terraform a future Mars and melt the ice caps and the water rises.
Right.
The problem is, boys and girls, that under current conditions, the waters could never get as high as the Tharsis Bulge. The bulge is too high. It sticks up 25 kilometers in the sky.
Hmm.
So how could he know there might have been an ocean, or could be an ocean, to lap at those cliffs, to create those cliffs? That's why I put the picture in the paper, because I think Arthur knows a little more than he's been telling.
Well, Arthur has always been very good at that kind of predictive science fiction.
In fact, we're sending him his own very special copy of this paper, and I will be able to tell you in a few days what he thinks. He'll either think we're totally cracked, or as I think most reasonable people will look at this.
I don't think you're totally cracked. I think this is quite reasonable. I'm not as sure of the fifth planet that you talk about, but the rest of this really does make sense.
Well, but here's our problem. If you've got
you need the fifth planet, I know.
You need a big guy from Mars to be a satellite of.
I understand.
So that's what tells me that Tom has been right. Now, has he been right about it blowing up, or has he just been right about its existence? Kind of doesn't matter. All right? Actually, it'd be kind of cool if we find that planets can blow up, because then we can find out ways to keep them from blowing up. You know, knowledge is important. Very important.
I would prefer the model where planets don't blow up.
Well, either way, you got to live with the universe you got. So if that's the universe we have, we need to know it, and Mars Odyssey with those radiation measurements will tell us. And you know the other neat thing it's going to tell us, Art?
Mm-hmm.
When it happened. Because what's the key signature of radioactive elements? They have half-lives.
That's right.
Which means you can reel back the clock.
That's right. Well, maybe this latest craft will tell us that. Listen, Richard, we're right at the end of the program. Is there anything you'd like to promo?
Well, go to the web and read the paper. And obviously, we want people to politic the planetary science community and NASA to look at this seriously. And if you want to know the backstory, in other words, if all the work we've done on Cydonia means anything in this context now, you might want to take a look at the Monuments of Mars or the video series we have. And there's an 800 number,
right, which is
1-800-350-4639. That's 1-800-350-4639. And the new 2001 edition of Monuments with some of this neat stuff in it will be going to the printer in September and available probably a month after.
All right. That's 1-800-350-4639. Wanted to get you to promo something for this gift you have given us. I hope a lot of people go and do the reading, and I'm sure some of them, Richard, I promise you, will get back to me.
I'll bet they do.
And I bet they do, too. And when they do, Perhaps we'll arrange some sort of debate. Perhaps we'll arrange another guest or two to come on with you, and we'll find out what they think of this new model.
This should be taken seriously and should be addressed at that level.
I understand. Wonderful night, Richard. Thank you as always.
Thank you, my friend.
Good night. All right, that's Richard C. Hoagland, and that was a lot about Mars, wasn't it? Tomorrow night, Sean David Morton will be here. Next week, we'll resume the 5-hour schedule. From the high desert, I'm Art Bell. Ta-ta.